The objective is to solve a 3 by 3 system of equations. Here's the first example. 7x plus 11y plus 12z equals a negative 168. 5x plus 7y equals a negative 4z, or minus 4z equals negative 62. And 5x plus 13y minus 8z equals a negative 100. You must solve for x, y, and z. We will do this by elimination. Your first general move is to create two equations that have only y and z in them, which means you're going to eliminate x in two of them. So here's what you can do first. You're going to choose two equations. There are three there, and we'll label them as 1, 2, and 3. You can choose 1 and 3, you can choose 2 and 3, you can choose 1 and 2, whichever. I am going to choose 1 and 2. And I need to eliminate the x's, which means I need the same number on the x's. I have 7 and 5. If I multiply these together, I get 35. So I want to multiply this entire top equation by 5. When I do that, I get 35x plus 55y plus 60z equals negative 168 times 5. And that comes out to be a negative 840. Now for the second equation. I have a 5x there. To get a 35, I would have to multiply it by 7. So if I multiply the second equation by 7, I get 35x plus 49y minus 28z equals a negative 62 times 7, which is a negative 434. So there's our first move, and from this we will generate a new equation that has only y and z in it. You have positive 35 x's on the left. To eliminate them to 0, the operation you would have to use is minus. 35x minus 35x is 0. But now we have to go through the rest of this. 55y minus 49y is going to be 6y. 60z minus a negative 28z. This is not 60 minus 28. This is 60 minus a negative 28, which will be a positive 88z. And then you have a negative 840 minus a negative 434. That'll be a negative 406. You're going to hold that where it's at. This equation is going to stay the way it is and where it's at for right now. You need to do the same thing we just did with two other equations. I am going to choose 2 and 3 because 2 and 3 have 5 x's already in there. So if we look at 2 and 3, it is 5x plus 7y minus 4z equals a negative 62, and then 5x plus 13y minus 8z equals a negative 100. We already have 5 x's on the left. There's nothing to change. So you can subtract those two equations to eliminate the x's. They are now gone. But 7y minus 13y is a negative 6y. And then we have negative 4z minus a negative 8z. That's plus 4z. And negative 62 minus a negative 100 is going to be a positive 38. You now have your second equation that has been generated. Go slowly and methodically, because if you put a wrong sign down, the rest of the problem is finished. All right, you have those two blue boxes that we have created. So what you are going to do with those blue boxes is to make your own little system out of them. You have 6y plus 88z equals a negative 406. And you have negative 6y plus 4z equals 38. Now, to eliminate the y's in this, you want to eliminate what's on the left, you would have to find something that would make them both the same number, like we did with the 7 and the 5 to make them 35. However, in this case, you have a positive 6 and a negative 6. There's no need to change anything. In order to get a 0 from doing something with 6y and negative 6y, would I subtract them or add them? You would have to add them. So if we add those together, the 6y and negative 6y are gone. And then we're left with a 92z equals a negative 406 plus 38. And that is a negative 368. Okay, so from there, you come back to this. Z equals negative 368 divided by 92. And if you divide negative 368 by 92, you come back with negative 4. So what we have just created now, even though you cannot see it, is a wedge formation with this and one of these, not both, one of them, and this first equation. We will create a wedge formation that you can then go in reverse and solve for the remaining items. So the first item in your wedge formation is going to be the first equation. 7x plus 11y plus 12z equals a negative 168. So let's write that down. And that was a plus 12z equals a negative 168. Now pick one of these two in the blue boxes. I'm going to choose the top one, so 6y plus 88z equals a negative 406. And then the last thing that you'll have in there is z. And z equals a negative 4. So if you'll notice, this creates some kind of a wedge formation there, like this. So you start at the bottom, and you know at the bottom you have z equals negative 4. So go back to the next equation up and put negative 4 in for z. That would be 6y plus 88 times a negative 4 equals negative 406. Alright, so 88 times a negative 4 is a negative 352. So you have 6y minus 352 equals negative 406. So keep your 6y where it's at, and you're going to have plus 352 on the right. So negative 406 plus 352 is a negative 54. If you were to come out with a decimal on this, it would be bad news, because I've made all of them to come out to be integers. Negative 54 over 6 is going to be a negative 9. So now we have negative 4 for z, negative 9 for y. So the last thing you would have to do is to plug in negative 9 and negative 4 in for y and z respectively in the very top equation. And when you do that, it's 7x plus 11 times a negative 9 plus 12 times a negative 4 equals a negative 168. Okay, simplify that and get 7x minus 99 minus 48 equals a negative 168. And a negative 99 minus 48 is a negative 147, so we'll have minus 147 here. On the right hand side, a negative 168, and you're going to add 147. You'll get a negative 21. So x would be a negative 3. Your final solution for this would be in order: negative 3 for x, negative 9 for y, and negative 4 for z. If on a test I give you blanks for x, y, and z, and you put negative 4 in for x, and negative 9 in for z, and negative 3 in for y, it is wrong. This is not an implied test that's coming up. It's a precise test. Just because you have the same numbers but in a different order does not mean they are right. It means you must have them in this order here. Negative 3, negative 9, negative 4. You caught on. Try this. Our first move is to use these two equations to create a new one with only y and z in it. You have an 11 and a negative 6 out here. You could make both of these 66s, one negative, one positive. Multiply the top equation by 6. So 6 times 11x would give me 66x, and then 6 times minus 13y is minus 78y, and then minus 42z, and then we're going to multiply the negative 71 by 6 and come up with a negative 426. Did anybody get that? Okay. Then you have to multiply the second one by 11 so we can match them up. So negative 66x plus 110y plus 77z equals 62 times 11. 62 times 11 is 682. Anybody have that so far? Okay, so you have 66 and a negative 66. Add those together to cancel these out to 0. And a negative 78 plus 110 is 32. So 32y, and negative 42 plus 77 is 35. So 35z, and then negative 426 plus 682 is 256. Alright, there is the first one that we have generated. So let's go to equations 2 and 3 and change those into 42s because we have 6 and 7. Multiply this one by 7, this one by 6. Okay, when we do that, we're going to come up with a negative 42x plus 70y plus 49z equals, and 62 times 7 is 434. Then on the bottom one, multiply that by 6 to get 42x minus, and that's going to be 14 times 6, which is 84. 84y, and then plus 13 times 6 is 78, so 78z, and then a negative 91 times 6 is negative 546. So add these together, and these will cancel out. 70 plus a negative 84 is going to be a negative 14y, and then 49 plus 78 is 127. And 434 plus a negative 546, negative 112. Those are the two new equations that you should have come up with. Now put those two together, and you're going to have 32y plus 35z equals 256, and then negative 14y plus 127z equals a negative 546. No, a negative 112, my fault. That's a negative 112. Okay, so now you have those two equations to work with. Now if you want to eliminate the y's, the easiest way is to simply multiply by 14 here and by 32 there. So multiplying by 14 on the top, that's going to give me a 448 y, and then plus 35 times 14 is 490 z, and then 256 times 14 is 3584. On the bottom, 32 times a negative 14 is going to be a negative 448. And then we'll have 32 times 127 is 4064. And then 32 times a negative 112 is a negative 3584. Okay, so when we add these together, these cancel out. And you end up with 4,554 z equals 0. Did anybody get z equals 0? Okay. Well then, you have to go back and set these up in a wedge form. So your first one is 11x minus 13y minus 7z equals negative 71. And then pick one of these two. I'm going to use 32 y plus 35z equals 256. And then of course z equals 0. So there is the wedge formation. If you plug this in for z in the second equation, you'll have 32y plus 0. It just cancels out to 0 equals 256. So 32y equals 256. Divide 256 by 32. 256 divided by 32 comes out to be 8. So we have this and this. So lastly, we have to do 11x minus 13 times 8 for the y, and then minus 7 times 0 for the z equals negative 71. So you can essentially just do 13 times 8 and come up with 104. So that would be 11x minus 104. This cancels out and set it equal to negative 71. Alright, so we're going to have 11x equals negative 71 plus 104. And a negative 71 plus 104 is going to be 33. So clearly x would have to be 3. The solution for this is 3, 8, 0.